Hi, today we are going to run through the topic SR flip-flop using NAND gate. SR flip-flops are also known as SR latch. It is a 1-bit memory bistable device which has two inputs. The first input is set, where in the circuit I have named it as S, and the second input as reset. In the circuit I have named it as R. Now let's move on to the construction of this particular circuit. There are 4 NAND gates present, where first and second NAND gate is being connected to the clock pulse. Third and fourth NAND gate is turned to be a latch, wherein the output of the first NAND gate falls as an input to the third NAND gate, where the second input of this particular third NAND gate is taken from the output of the fourth NAND gate. You can see a closer look over here. The output is turned to be an input for the third NAND gate, that is QN complement. Likewise, if you look into the fourth NAND gate, the output of the second NAND gate falls as an input to fourth NAND gate. The second input is taken from the output of third NAND gate. The connection goes this way. So here the input is QN, where this particular inputs fall static for all the cases. In this circuit, QN and QN complement are the outputs. Move on to the working condition. Case 1, set is equals to 0, reset is equals to 0, and the clock pulse is equals to 1. That is, S is 0, R is 0, and the clock pulse is 1. With reference to the NAND gates truth table, 0 and 1 as an input, 0 and 1 as an input, the output of the first NAND gate is 1. Considering the second NAND gate, 1 and 0 as the two inputs, 1 and 0, the output is 1. Now let's analyze the latch. Before we proceed with the latch, just take a closer look onto the NAND gates truth table, where the expression is Y is equals to A into B complement, where Y is the output, A is the first input, B is the second input. First and second input is being multiplied and complemented. I am applying this particular expression for the third NAND gate. So Qn is equals to, the first input is 1 and the second input is Qn complement. Taking the reference of the expression, you can see here Y is equals to A into B, the whole complement. I am complementing both the values. Now, Qn complement into 1 is Qn complement. I am writing this particular complement over here. So, the answer is Qn. Proceeding with Qn complement is equals to, the first input is 1 and the second input is Qn. Reference to the expression, I am complementing it. So, Qn is multiplied with 1, it is Qn. I am writing the complement as the same. So, the answer of Qn is Qn. Qn complement is Qn complement. So, there is no change. So, the entire circuit falls under the condition of no change. Let's move on to case 2. Set is equals to 0, reset is equals to 1, and clock is equals to 1. That is, S is 0, R is 1, and the clock pulse is 1. With reference to the NAND gate, when 0 and 1 as an input, the output is 1. 1 and 1, the output is 0. Now let's analyze the latch. Considering Qn is equals to, the first input is 1 and the second input is Qn complement. With reference to the expression, I am complementing it. Qn complement into 1 is Qn complement. This complement I am writing over here. So the answer is Qn. Considering the second output, Qn complement, that is equals to, the first input is 0 and the second input is Qn. So from the expression, I am just complementing it. Qn multiplied with 0, it is 0. I am writing down this complement. 0 complement is 1. If Qn complement is 1, then Qn turns to be 0. As Qn complement is high, the entire circuit falls under the condition of reset. Case 3. Set is equals to 1. Reset is equals to 0 and the clock is equals to 1. That is, set is 1, S is 1, R is 0 and the clock pulse is high. That is 1. Now, considering the NAND gate's truth table, 1 and 1 has an input, the output is 0. The output is 0 and in the second NAND gate, 1 as an input, 0 as an input, the output is 1. Now let's move on to the latch. Qn is equals to, the first input is 0 and the second input is Qn complement. Reference to the expression, I'm just complementing it. Qn complement into 0 is 0. I'm writing down this complement. So the answer is 1. Now Qn complement is equals to, the first input is 1 and the second input is Qn. With reference to the expression, I'm complementing both. Qn into 1 is Qn. I'm writing down the complement here. As Qn is equals to 1, now Qn complement turns to be 0. As Qn is 1 and Qn complement is 0, the entire circuit falls under the state of set. Case 4. Set as 1. Reset is equals to 1 and the clock pulse is equals to 1. That is, S is 1, R is 1 and the clock pulse is 1. In that case, 1 and 1 with reference to the NAND gate, it is 0. 1 and 1 for the second NAND gate input, the output turns to be 0. Now let's consider the latch. Qn is equals to, first input is 0 and the second input is Qn complement. With reference to the expression, both the values are complemented. So Qn complement into 0 is 0. I'm writing down this whole complement over here. 0 complement turns to be 1. Considering the second output, that is Qn complement equals to, the first input is 0 and the second input is Qn. With reference to the expression, I'm just complementing it. Qn into 0 is 0. I'm writing down this complement over here. 0 complement is 1. If you observe, both set and reset is high, so it turns to be a indeterminate state, which is not valid. It is invalid. Both set and reset cannot be high at the same time, so it turns to be indeterminate, that is invalid.